Good afternoon, class. Here's chapter 6, periodic / trigonometric functions, section 6.3, inverse trigonometric functions. Here's part 1. So we've covered graphs of sine and cosine, other trigonometric functions, phase shift, and now the inverse functions. And the objectives are to find the exact value of an inverse sine, cosine, or tangent function. Find an approximate value of an inverse sine functions. Use properties of inverse functions to find the exact values of certain composite functions. Find the inverse function of a trig functions. Solve equations involving trigonometric functions. Again, reminding you of the properties of trigs, such as unit circle, x squared plus y squared equals 1, and a point having coordinates x and y. X represents the cosine, y represents the sine, tangent is y over x, and the rest of them are reciprocals. If you have a radius r in general, x squared plus y squared equals r squared, so sine is y over r, cosine is x over r, and the rest of them. Fundamental identities, Pythagorean identities such as sine squared plus cosine squared equals 1, and so on. Quotient identities such as tangent is sine over cosine. Reciprocal identities such as cosecant is 1 over sine, and so on. Even and odd properties. Even means f of minus x equals f of x. Odd means f of minus x equals minus f of x. Also, trigonometric functions are odd except cosine and therefore secant. And a periodic function repeats its value at regular intervals. Trigonometric functions are periodic, where in this case k is an integer. Therefore, sine of theta plus 2k pi is equal to sine theta. The period is 2 pi for all trigonometric functions except tangent and therefore cotangent. As far as the graphs are concerned, whether we are dealing with sine or cosine, the basic cycle, a complete cycle, goes from 0 to 2 pi. We cut that into 4 equal parts, and we evaluate the end points, and it creates 1, 2, 3, 4, 1, 2, 3, 4 arcs. 4 sub-interval corresponds to 4 arcs. You notice sine is the same as cosine of x minus pi over 2. In other words, cosine when it's shifted to the right by pi over 2. In general, when y is sine or cosine, the period t equals 2 pi, amplitude is 1. If it's a sine omega x or y equals a cosine omega x, the period is t equals 2 pi over omega, and amplitude is the absolute value of a. As far as the phase shift is concerned, when we have y equals a sine omega x minus phi, remember, and we are assuming a and omega and phi are positive, the period t gets divided by omega, so period is 2 pi over omega. And if you take the omega out, this becomes phi over omega, and that's the amount that has been shifted to the right, called the phase shift. And so the general format, if we have a vertical shift also, such as b here, then we are going to rewrite this by taking the omega out, and phi over omega is the phase shift. Now, all of them remain the same. The amplitude is absolute value of a, period is 2 pi over omega, phase shift is phi over omega. If phi is less than 0, PS, short for phase shift, is to the left, and if it's positive, it's to the right. In some texts, including this text, they may use the format y equals a sine of bx minus c plus d. So you have to find a, b, c, d. And of course, whenever you have these parentheses, you take the b out, and this becomes x, and this becomes minus c over b, meaning you rewrite this a sine of b x minus c over b plus d, and this becomes the phase shift. Okay. If it's assuming C and B is positive, minus C over B takes it to the right by this much. If it's plus C over B takes it to the left by that. And now the inverse 6.3, the inverse sine, cosine, and tangent functions. Review of properties of functions and their inverses. Only one-to-one functions have inverse functions. If f has an inverse, then f or f inverse of x equals x, the composite function x, in the domain of the second piece, f inverse, and f inverse O f of x is also x, and this x is in the domain of f of x. The domain of f of x is the range of f inverse, and the range of f of x is the domain of f inverse. Remember, when we look at the concept of inverse functions, the domain of one is the range of the other. The graphs of f of x and f inverse are symmetric about the line y equals x when graphed on the same axis. Composition of inverse functions. F O f inverse of x equals x, f inverse O f of x equals x with a proper domain. So this is the synopsis of what we need to move on. So when we look at a sine function, or for that matter, any of the trigonometric functions that we have, we know they are periodic and none of them is one-to-one. In fact, sine and cosine, even one period, fails the horizontal line test, and therefore it doesn't have an inverse. However, we can do the restriction, make it one-to-one, and therefore it has an inverse. Notice y equals sine x, the domain is all real numbers, y goes from -1 to 1, and it's not a one-to-one function. Now, if we restrict it from minus pi over 2 to pi over 2, what happens? First of all, you have a continuous function, you have one piece. Secondly, you cover all the range from -1 to 1, and now that, only this portion is a one-to-one function. So, just this portion, and we are going to say y equals sine x. If we restrict the x between negative and positive pi over 2, we cover all the range, and this is a one-to-one function. Therefore, when we say y equals sine inverse of x, by definition of an inverse function, x becomes sine of y. X is between -1 and 1, and y is between negative pi over 2 and pi over 2. In other words, domain of a sine becomes the range of sine inverse. Range of sine becomes domain of its inverse. So this is the range. This is the domain for sine. And by definition of the inverse, they interchange. Now, We want to graph its inverse. So all you have to do, pick up a few easy points and figure out what you get. For example, if you look at this point, minus power 2 minus 1, 0, 0, power 2, 1, those are easy points. All you have to do, interchange. So this becomes minus 1 minus power 2. This doesn't change 0, 0. This is 1 power 2 on the graph of the inverse function. So minus 1 minus power 2 here, 0, 0 doesn't matter. Power 2, 1 becomes 1 power 2. Putting them together on the same set of axes, the function y equals sine x and its inverse with the restriction on the domain, which gives us a one-to-one function. So very straightforward. We can move on. Find an exact value of an inverse sine function, sine inverse of 1. Let's call it x, y, z, theta, you name it. And of course, reminding everybody of this, right? So let's call it theta. Therefore, by definition, look at this very first line, sine of theta must be 1. Remember the graph? And you know sine of theta equals 1 when theta is power 2. So we're going back to the sine theta. Of course, it's a common arc. We should know that. Sine inverse of 1/2, we let it equal alpha, beta, gamma, theta, doesn't matter. By definition, therefore, sine of theta is 1/2. That's a common arc, theta equals power 6. Now, what I want to mention here, class, when we look at the inverse function, we are looking at negative power 2 to power 2 for sine, if you will, okay? As far as the domain is concerned. Therefore, it creates one solution. Whereas if you are solving this from 0 to 2 pi, it does have two solutions. Again, this has a unique solution because of the restriction we put on sine to make it 1-to-1. Just one solution. Negative 1/2. Let's call this again theta. And according to this, sine of theta must be negative 1/2. As you know, sine is negative in the fourth quadrant, so that makes it negative power 6. And you have to answer it accordingly because of the restriction we put on theta from negative power 2 to power 2. You have to answer in this interval. In this case, becomes minus power 6. Now finding an approximate value of an inverse sine function answered in radians for decimals. A sine inverse of 1/3, you put that into a calculator. It looks like this sine inverse of 1/3. It has a key for that. And we want to go with 4, 1, 2, 3, 4 decimals, 8. After that is 3, it doesn't change, 0.3398 is the answer. Again, you have to make sure it's in radian mode. Sine inverse of negative 1/4, put it into a calculator. Sine inverse of negative 1/4 gives you this answer, 1, 2, 3, 4. Number 6, you stop. Next to it is 8, goes up to 7, so negative 0.2527 is the answer. Sine of a sine inverse of a 0.5. It's important for this number to be in the domain of this function. That means sine inverse. So x must be between negative 1 and 1 it is. So therefore, we follow f of f inverse of x equals x. The answer is 0.5. If you were to put it into a calculator, it would say sine of sine inverse of 0.5 is 0.5. What about sine of sine inverse of 1.8? This must be in the domain of sine inverse. So sine inverse, its domain is from negative 1 to 1. It's undefined. Another way that might make it easier to understand, you could say the following. You could say that this part, you're going to write sine inverse of 1.8 is x. That means sine x equals 1.8, and this has no solutions. Sine is between negative 1 and 1. If you put it into a calculator, it gives you an error. Okay. You go to your calculator, you check the mode, so it's in radian mode. So for example, you can say second sine, that's the sine inverse of, let's say, 1/3. And you get 0.3398, the number that we had here. Let's clear it. Second sine, that means sine inverse. We want negative 1/4, close parentheses, and we get the number that we had here. So that's how it works. All right, so I wanted to show you the calculator and also. Find the exact value of the following composite function, sine inverse of sine of pi over 8. And remember again, this must be in the domain of this function. This function is sine. So pi over 8 is in its domain. Therefore, the answer is pi over 8. They undo each other in essence. That's the meaning of inverse functions. Sine inverse of sine of 5 pi over 8 is 5 pi over 8 in there, and obviously it's not, right? Because remember, 4 pi over 8 is pi over 2. 5 pi over 8 is larger than that. It's not. And that puts us in the second quadrant. What you can think of it is that it's the same as sine of pi over 8 in essence, okay? But in the second quadrant, let's look at this. Find an angle in the interval for which sine theta equals sine of 5 pi over 8. So in essence, you need the reference arc. So right here, I just want to remind you, this is in quadrant 2. And in quadrant 2, reference arc is pi minus theta. So that makes it pi minus 5 pi over 8, which gives you 3 pi over 8. So that's the answer. However, if you want to look at it slightly different, quadrant 2, as I mentioned, the sign is positive. So if this is 5 pi over 8, this angle is 3 pi over 8. This is the reference arc class. So this is theta. This is the reference arc. Okay. And so you can look at this one, see that they have the same y coordinate, if you will. Different a's, but this is positive versus negative, and they have the same y coordinate. And so sine inverse of sine of 5 pi over 8 is the same as sine inverse of sine of 3 pi over 8 or 3 pi over 8, or just the fastest way. If it's in the second quadrant, find the reference arc. That's all there is to it. If it's in the third quadrant, sine is negative. Find the reference arc and negate that because it has to be in this, fourth quadrant. Now let's look at cosine. Cosine, just like sine, it is not a one-to-one function because y equals cosine x, and domain is all real numbers. Y is between -1 and 1, the range, but it fails a horizontal line test. It is not a one-to-one function. So what do? We do the same thing as we did with sine. We do the restriction, but here's the important part. The restriction must be such that the entire range will be there. We can't lose anything. And so the reason we go from 0 to pi because it covers the range. And if we want to choose anything else, it may not be continuous. So we want a continuous piece. Okay. So now if we choose this part and this part only, this is continuous. And now y equals cosine x. We restrict the domain, which is all real numbers, to 0, from 0 to pi. The range, of course, does not change, and it makes it a one-to-one function. And that's what we are looking for. So now, when y equals cosine inverse, by definition, x becomes cosine y. The domain is 0 to pi here, becomes the range. The range is negative 1 to 1, becomes the domain. And so if we look at those easy points, 0, 1, pi over 2, 0, pi, negative 1, we're going to interchange x and y, everybody. One, 0, 0 pi over 2, negative 1 pi. So remember, pi is 3.14 roughly. So it's about 1.5. So maybe here is about 1, 0. 0 pi over 2 is somewhere here. Negative 1 pi is here. So looking like this. So graphing both of them on the same set of axes. Pretty straightforward, everybody. Find the exact value of inverse cosine function, starting with cosine inverse of 0. Let's call it theta. By definition, cosine of theta becomes 0. So you're going to ask yourself, if cosine theta is 0, theta must be pi over 2. It's one of those common arcs we should know, everybody. Cosine inverse of 1/2, let's set it equal to theta. By definition, cosine of theta must be 1/2. Theta must be pi over 3, a common arc, everybody. Cosine inverse of negative 1/2 is theta. By definition, cosine of theta becomes negative 1/2. Remember, we restrict the domain from 0 to 2 pi. Cosine is negative in the second quadrant. When it's positive 1/2 is pi over 3. When it's negative 1/2 has the same reference arc. Now for this one, reference arc would be pi over 3. So subtract this in the second quadrant. Subtract this from pi, and the answer is 2 pi over 3. This I'm showing you how to find that. The last one, we said equal to theta. Again, it's cosine theta is negative square root of 2 over 2. I want to make sure we can find this easily. So let's say cosine theta is square root of 2 over 2. That means theta is pi over 4. That means pi over 4 acts like reference arc for that. Because it's negative, you subtract pi over 4 from pi. The answer is 3 pi over 4. So I hope everybody knows how to find those nice and easy. Find the exact value of the following composite functions: cosine inverse of cosine of 5 pi over 6. And again, reminding everybody about composite functions, we mean f of f inverse is equal to x as long as we have the right domain. So this must belong to the domain of cosine. And as you know, cosine is between 0 and pi. Is this between 0 and pi? Yes. The answer is itself. You're done. 5 pi over 6 is an element of, I think I've discussed that this notation in set theory is read an element of that belongs to the given interval. Now, cosine inverse of 0.2. So you look at cosine inverse. For cosine inverse, x is between -1 and 1. Is this number in between? Yes, the answer is 0.2. So instead of writing this over here, I wrote this notation. I want you to see that these two are the same. Cosine inverse of cosine of 5 pi over 4. Now, is this between 0 and pi? The answer is no. Why not? Because 5 pi over 4 is larger than pi. 4 pi over 4 is pi. So what is the process? Very simple. 5 pi over 4 is not between 0 and pi. Find an angle with the same cosine value, which belongs to this. Remember, the restriction is from 0 to pi. When it's 5 pi over 4, it's in the third quadrant and it's negative. First and foremost, the moment you look at this, you should recognize the reference arc is pi over 4. And the reason you know it's negative because it's in the third quadrant. You know cosine is also negative in the second quadrant, right? And in the second quadrant, we are going to use pi minus the reference arc. Pi minus pi over 4. Why is that okay? Because that puts us between 0 and pi. Cosine of 5 pi over 4 is the same as cosine of 3 pi over 4, and therefore the answer is cosine of 3 pi over 4 instead of that. The answer is 3 pi over 4. Very straightforward, everybody. Cosine of cosine inverse of 2. So you look at cosine inverse. Has to be between -1 and 1. It can't be, therefore it's undefined. This one, the second method is just as easy as I showed with the sine. Say cosine inverse of 2 is alpha, beta, gamma, theta. You choose it by definition. Cosine alpha must be 2, and that doesn't exist. Cosine is between -1 and 1. Let's look at tangent. Just like sine and cosine, it's a periodic function. It fails the horizontal line test. It is not a one-to-one function. So y equals tan x. Domain is all real numbers. X can't be 2n plus 1 times power 2. Remember that? Those become the vertical asymptotes. Y, no restrictions, are real numbers, and it's not a one-to-one function. However, if you just pick one complete cycle from minus power 2 to power 2, it covers everything you want. It is a one-to-one function, and we can write when y equals tan x, x is between negative power 2 and power 2, y is between negative infinity to infinity, and it becomes a one-to-one function. And so we are going to write y equals tan inverse x means x equals tan y. That's the meaning of it. When x is between negative and positive infinity, because remember, range is y between negative and positive infinity for the function tangent, becomes the domain for its inverse, and then y is between negative power 2 and power 2. That was the domain of tan x, which becomes the range of its inverse. So we pick a few easy points for the sake of graphing. Obviously, you remember minus minus pi over 4, -1, positive pi over 4, +1, and 0, 0. So we have those three pairs, and we have the vertical asymptote x equals minus power 2, x equals power 2. We write those. So interchange, you get -1 power 4, you get 0, 0, you get 1 power 4. Vertical asymptote become horizontal asymptote. Y equals minus power 2, y equals power 2. So 0, 0 doesn't change. -1 power 4, -1, negative power 4 is somewhere here. And +1 power 4 is somewhere there. So it looks like that. And if you graph it, you get this function with two horizontal asymptotes. Let's look at a couple of examples. We're going to find the exact value of the inverse tangent function in this case. All right, starting with tan inverse of 1, let it be alpha, beta, gamma, for example, theta, and by definition means tan of theta equals 1. We know the answer is pi over 4. You said this one equal to theta? By definition means tan of theta must be negative square root of 3. We are looking at easy and common arcs, okay? And remember, for square root of 3 is pi over 3. So for negative square root of 3 is negative pi over 3. Just like similar to sine conceptually when it comes to finding the answer, and there's a unique answer. Set this equal to theta, and by definition, tan of, theta must be this number, square root of 3 over 3, and you know it to be pi over 6. Same thing here, set it equal to theta. By definition, tan of theta must be this number, and therefore it's the same thing, negative, because that's the nature of tangent. So minus pi over 6. Okay. Solve equations involving inverse trig functions. For example, 2 cosine inverse of x is pi over 2. We are going to divide by 2. Cosine inverse becomes pi over 4. By definition of inverse, x becomes cosine of pi over 4. And we know that one is square root of 2 over 2. Bear in mind, again, I can't emphasize this enough, that this makes it a unique answer. There's only one answer when you have cosine inverse. Whereas if we said cosine of x is equal to square root of 2 over 2, we will have more than. And so how about this one? 3 sine inverse of x is pi over 2. We are dividing by number 3, and we get pi over 6. By definition, x becomes sine of pi over 6. It's a common arc. We know the answer is 1/2. We move things around as follows. We move this here. We make it minus 2 sine inverse of x. We make this positive 2 pi. We get 3 sine inverse of x equals minus pi. Divide by 3. Sine inverse of x equals minus pi over 3. By definition of an inverse function, sine of minus pi over 3 is x. And you can just answer it because you know sine of minus pi over 3 is minus square root of 3 over 2, or you can even write it as minus sine of pi over 3 because it's an odd function. And now you know this one is square root of 3 over 2. The negative in front will negate that. Either way is fine. Find the inverse trigonometry functions, domain and range. Find the inverse function, f inverse of f of x. Being f of x is given as 2 sine x minus 1, and x is between negative power 2 and power 2. Remember, we restrict the domain. And if they have any other restriction, we follow. Find the range of f and domain of domain and range of f inverse. So first, we are looking at f of x. And we want to find its inverse, so we are going to change the name to y because it makes it easier to work with. That's the only reason. Interchange x and y. This becomes x, this becomes y. Right here, we have the inverse, but we solve for y. So we move the negative 1 and we divide by 2. We move the negative 1, becomes positive 1 on the left. We divide both sides by 2, and x plus 1 over 2 becomes sine y. Therefore, by definition of an inverse, sine inverse of this piece becomes y. And we give it a name f inverse. So y, or f inverse of x, is sine inverse of x plus 1 over 2. In other words, when f of x is 2 sine x minus 1, f inverse is sine inverse of x plus 1 over 2. And you can look at the composite function, by the way. And now we want to continue finishing the job as far as the domain and range is concerned. So when we go back to this guy, this was given as its domain. Recall that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Therefore, this becomes the range of its inverse. So range of f inverse of x, meaning y now, is between negative power 2 and power 2. We didn't have to do much, just remembering this theorem, right? Sine inverse, regardless of what it is, the domain for the inverse is between negative 1 and 1, right? So sine inverse, the domain is between negative 1 and 1. So therefore, instead of x, any expression here is between negative 1 and 1. Let's multiply both sides by 2. We get minus 2 less than or equal to x plus 1 less than or equal to 2. Let's subtract 1. X is between negative 3 and 1. This is the domain of f inverse. Domain of f inverse is range of f. So range of f, y is between negative 3 and 1. Of course, x inclusively, the endpoints are included. And we are done. I want to show you different methods in case. Here's the second method. Going back here, if we solve for sine, meaning take the -1 to the other side, becomes y plus 1 divided by 2. I'm hoping from here to here is not a problem. And sine must be between -1 and 1, right? So that means this expression must be between -1 and 1. Now work on this. If you multiply, I'm going to leave it for you. If you multiply this one by 2, you get -2. This goes away. This becomes 2. Subtract 1. And again, from here to here, couple of steps in between. I'll leave it for you to finish it. But here's the second method that I wanted you to see. Okay, everyone? So range of f, method 2. Range of f, method 3. If sine x is between -1 and 1, that is a known fact. Make it look like 2 sine x minus 1. So you're going to if I multiply by 2, I get 2 sine x. I get -2, I get 2. Multiply by 2. I want it to look like that. Subtract 1, subtract 1, subtract 1, subtract 1. So 2 sine x minus 1 is between -3 and 1. That means the range. So this is another method. Again, I wanted to mention those methods and you decide which one works the best for you, okay? Find the inverse trigonometric function domain and range. In this case, find the inverse function f inverse of this function. F of x is 2x, 2 cosine of 3x plus 2. And here's the given domain. X is between -2/3 and -2/3 plus power 3. Find the range of f and the domain and range. So first and foremost, ignore that, find the inverse. F of x is this. Change it to y because that makes life easier to work with. Interchange x and y. This becomes x, this becomes y. Divide both sides by 2. By definition of an inverse, cosine inverse of this side, cosine inverse of x over 2 is the argument of cosine 3y plus 2. You're solving for y. Make this -2. So I'm going to write it here. We have cosine inverse of x over 2 minus 2 equals 3y. Divide by 3. And that's y. Call it f inverse. So when you divide by 3, you can say 1/3 of cosine inverse of x over 2 minus 2/3. We have the function f of x. We have its inverse. We've already discussed the domain and range. Here's the domain for f of x, which becomes, again, according to this, becomes the range for f inverse. So instead of x, you put y, and that would be the range of f inverse. You're done. as far as domain and range of these two is concerned. Now you need domain of F inverse, a range of F. Domain of F inverse, when you look at 1/3 cosine inverse of x over 2, this is the restriction, so x over 2 must be between -1 and 1, right? X over this expression, in this case is x, so cosine inverse of this expression happen to be x over 2, whatever. It's important to understand how we arrive at it. Use a different color. This expression, cosine inverse of this expression, the expression here is x over 2. So x over 2 is between -1 and 1. Multiplying by 2. X is between -2 and 2. That is the domain of F inverse, which becomes the range of F. When we say range of F, we change it for Y, okay? So this is done. I want to just quickly show you the second method. So this is done. You don't have to do anything else. The second method, if you go back here, y equals 2 cosine of 3x plus 2, and y is between -1 and 1. As far as the cosine is concerned, right? Now, 2, okay, so cosine is between -1 and 1. 2 cosine of 3x plus 2, then I need a 2 here. I'm going to multiply by 2. Let me erase my word class so it becomes easy to see. When I multiply by 2, this becomes -2. This becomes the right side. This becomes 2. And therefore, y is between -2 and 2. So we use this side, starting with what we know, which is cosine. And this is the second method, and we are done. Example 10, find the inverse function f inverse of f of x, where f of x is 2 tan x minus 3, and x is between -power 2 and power 2. Also find the range of f, or domain and range of f inverse. So first and foremost, I want to make sure we understand this is the function that we are working on. We call it y because it's easier to work on y. We interchange x and y, and we want to solve for y, so we're going to move -3 becomes +3, so we have x plus 3, and we're going to divide by 2. And now, by definition of inverse tangent, y is tan inverse of the left side, x plus 3 over 2. And we give it the name f inverse. So we're done finding the inverse. The domain for f of x is given, therefore that's the range for f inverse. Domain of f of x is given as -power 2 to power 2. Again, reminding you that domain of one is the range of the other and vice versa. Therefore, the range of f inverse is the same thing. So again, bear in mind, this is x between -power 2. This is y between -power 2 for f inverse. Now we want to find domain of F inverse, range of F. If we go to F inverse, X is between negative and positive infinity, meaning whatever this expression is. So this one is between negative and positive infinity. And so you multiply by 2, and it becomes 2 times negative infinity is still negative infinity. Class, infinity is a concept, and this becomes very important to understand when we go to calculus. So when I multiply infinity by 5 or 10, or if I divide it by 20,000, or if I take a square root, it remains as infinity. Now, I subtract 3 from all sides, makes no difference. Okay, so actually, let me erase my work. So the fact remains that whatever you do, it doesn't change that. So X is between negative and positive infinity, domain of F inverse, which is range of F. Here's the second method that we can look at. If you go to this function, y, which represents 2 tan x minus 3, we know tan is between negative and positive infinity. Multiplied by 2. When you multiply it by 2, class, this becomes 2 tan x becomes 2 times minus infinity is still 2, is still negative infinity, 2 times infinity is still infinity. Subtract 3, add 3, whatever you do, the infinity and negative infinity don't change. So that's the second method to find the range here. Find the inverse function, f inverse of f of x equals 3 cosine x plus 1, and x is between 0 and pi, and we want to find the range of f and domain and range of f inverse. I wanted you to be exposed to a lot of examples. This is important, class. That's why I did quite a few here. So f of x is 3 cosine x plus 1, and we change it to y because it's easier to work with. Interchange x and y, this becomes x, this becomes y, because we are finding the inverse. And again, I remind you, right at this step, we do have the inverse, however, we solve for y. So 3 cosine y is x minus 1, move the 1. So 3 cosine y is x minus 1. So in essence, we move this one, and now divide by 3. And by definition of an inverse function, y becomes cosine inverse of x minus 1 over 3, which we call it f inverse. We are done finding what we were looking for. Domain is given. Again, reminding you, domain of one is range of the other. So range of its inverse, f inverse, is the same thing, meaning range of f inverse, y is between 0 and pi. That's how we write that. When we go back to this expression, for cosine inverse of x is between these two numbers. So therefore, this must be between those two numbers. X minus 1 over 3 must be between those numbers. And so let's multiply both sides by 3 to get rid of the denominator. We get negative 3 less than or equal to x minus 1 less than or equal to 3. Let's add 1. X is between negative 2 and 4, which makes it domain of f inverse, range of f. So range of f, y is between negative 2 and 4. And I want to quickly show you the second method. We know this is y, and we know cosine is between negative 1 and 1. So this is the y, cosine is between negative 1 and 1. We want it to look like this, right? Multiplied by 3. We want it to look like this. Add 1. And so the answer is the same. As you can see, the range is between negative 2 and 4. Two different ways.